How's it going, everybody? In our next section of L2VPN, we're going to move away from the Xconnect variation of it, and we're going to start diving into some of the newer methods and capabilities that are out there. So, as you'll find as you progress into L2VPN, there's actually a lot of different variations to it, especially on the MPLS side of the house. So, what we're going to start diving into is understanding some of the constructs and terms and things like that, because we really haven't dove into that too much. So I'm going to lay out some of the groundwork and try to help illustrate what's actually happening here from an operational perspective, and then we'll start diving into some of the more technical bits in upcoming videos. So I'm going to go ahead and start doing a little bit of whiteboarding. I'm going to go ahead and get out of the way here. So one of the first things that we need to understand terminology wise is the connection from the CE to the PE and the PE to the PE and then the PE to the CE. Okay? So any type of CE to or from the PE is referred to as the attachment circuit. So I'll go ahead and pause and write all this out. Now basically what the attachment circuit is, this is going to be your last mile connection, where it's the connection between you and the provider. And this can be terminated a number of different ways. It can be terminated via a router. It can be terminated via a switch where you have other connections coming into it. So for example, you could have the PE router here. You could have an attachment circuit delivered that's terminated into a switch, and then this would be a trunk link per se, and then you could have a number of connections coming off of this going to, a variety of different customers and things like that. So this could be a multi VLAN breakout, and then you run a VLAN. So let's say you run VLAN 10, you run VLAN 20, you run VLAN 30, 40, and then 50, for example. And then each one of these customers is a separate connection off to the service provider. There's another way where you take that same provider edge, so this would be the PE, this would be the CE, and then you run this guy down to a router. And then you can do whatever tagging you need to. So this would be a routed, this would not be a routed connection, but you could run either 1 through 4094 VLANs, right? It could be a trunk link, but you normally wouldn't do that. This guy right here would be an IP address enabled interface. So you would put an IP address on this interface right there, like we have on the CE side so far, and then you can have some sort of other infrastructure that PE connects to, and then you have another PE down here, and this guy right here terminates to another router, and this guy could be .2, for example, and this guy right here, so in between here and here, this could be the 10.1.1.0/24, and these guys would be able to talk to each other. They would be able to form an EIGRP adjacency with each other as well. So there's a number of different scenarios that you could go into as you're going into the details of how all this stuff comes into play and its operations and things like that. So in those capabilities and those characteristics, you would take the capability that you're bringing in, and you would have to understand exactly what the customer needs are. So let's talk about this one a little bit more in detail. So let's go ahead and let me just clear the before I go do that, let me talk about this last portion right here, the connection between the PE routers. So let's talk about this from a logical perspective. So we understand the attachment circuit, right? It's how the customer connects to the service provider, right? And that could be terminated either via switch or it could be terminated via a router. Doesn't really make much of a difference. I'll talk about the switch logic here in a little bit more detail. I'm actually going to add a switch to this environment and give you a couple of examples, but right now we're not at that point yet. This connection between the PE routers. Think of this like a a tunnel. And this tunnel is set up, it's a point-to-point connection between the PE routers. Now, when you're dealing with a point-to-point style connection, this is also referred to as Virtual Private Wire Service, or VPWS. And the idea is actually very simple. It's a point-to-point connection, logical point-to-point connection between two provider edge routers. Now, just like you would have had if an MPLS layer 3 VPN, where you have two PE routers that are sending and receiving route target values for a layer 3 VPN customer, and there's BGP peerings, and then customer 1 site 1 and customer 1 site 2 have peered and they're advertising prefixes back and forth. That's a point-to-point connection, right? No other provider edge routers are involved in route propagation and things like that. Same concept applies here. So when would you use this? Well, very simply, if you need to just bridge two sites together. This is very common with what they call dark fiber, where you have a customer that has a fiber connection to the service provider, and they call up the service provider and say, hey, I need to set up a connection between this location and this location, but I don't want to use the internet to get there. I want to have a point-to-point backdoor link for replication or for backups or whatever the case might be. A very, very common scenario that I've been tasked with having to provision or get up and running. So dark fiber is very common. If there's already fiber existing in that area, I can run a circuit to that particular company's building, and sometimes there's a construction build out associated to that, other times not so much. But the basic goal that we're trying to accomplish is, if I go and I have a customer 1 site 1 and I have customer 1 site 2, and I have some sort of internet connectivity out here that they're both peering to, right? But then they're like, you know what, I don't want to use my 100 megabit internet to do replication because I've got users on the internet, I've got users doing a bunch of other operations. I don't want to really tie that up. So you could have like virtual machine backups and a bunch of other stuff. It could be any number of reason why you need it. I personally don't care. Whatever business use case you present to me, I really don't care. I just need to know, like, you want this to be a backup, or you want to have another connection that isn't going to ride an already in place transport, whether it's internet or MPLS layer 3 VPN. You want to have a point-to-point connection. To me, that's an important aspect of this. Very commonly deployed. There are lots of customers that I've worked with have had this deployed, and it's widely leveraged. So you would end up setting up a connection where you would terminate like on a router or a switch, and then you'd have I'm going to draw a LAN segment between these two because that's really what it'll end up becoming, right? And then you have this device is then set up to connect to the service provider's layer 2 VPN infrastructure. Now, the reason why I drew a LAN segment is because you could have customer 1 site 3 added to it, and there's another box added to this link, and he's added here, and this would allow you to scale this solution to where you can start adding multiple sites to this deployment method and scale it out to where if you need to replicate between two primary sites and then maybe a offsite disaster recovery data center or colo facility or something along those lines, is very commonly done as well. The cool thing about it is everybody here is on the same subnet, right? So we're on a /24 prefix. This would be .1, this would be .2, this would be .3, and I can route in between these all day long. It would be, I could form an EIG or P adjacency between these three sites, and then based off of whatever configuration I set up, I can go, okay, I can have static routes internally. I could have static routing set up, or I could do a redistribute static or redistribute connected. I could bring this layer 2 connectivity into the environment, and then I could say, like I said, it persistent routes on a server and go, okay, if you want to get to this particular destination, go this particular path. So it's very cool being able to manipulate this however you need to and get things working. Now the whole point of this is this right here, this connection between the devices is enabled via this connection. This is what they refer to as the pseudowire. The pseudowire is going to be a mechanism used to generate a label. So you're going to have two different labels to consider. You're going to have the transport label, which is, for those of you that went through the layer 3 VPN videos, you know is the label that you usually get from the ingress PE to and from the egress PE, right? And that's basically how that works. The transport label gets you from here over the MPLS backbone infrastructure to this guy. So you have that construct. Then you also have the next one, which is the VPN label. The VPN label is actually associated via the pseudowire construction setup. So whenever a pseudowire is created, a VPN label is also created. The VPN label is what ties the traffic to the actual pseudowire. So it's a point-to-point connection. So if you were ever to do a Wireshark capture like we did, you'll see a transport label. This is used to get from the ingress PE to the egress PE, right? And then the VPN label is for the data plane, right? So the transport gets you from ingress PE to egress PE, and the VPN label gets you in the data plane. That's how the traffic is moved from PE1 to PE2. And the cool thing about it is when you're sending the traffic, there is no like visibility as to what's actually happening. The service provider network is transparent. Much in the same way, if you were to take a Cisco, or take any switch, I don't care what brand it is. I have a Netgear, an 8-port gigabit network. I have an 8-port gigabit Netgear switch in my basement that is providing the connectivity between my storage area network. So I have a little QNAP storage appliance with 12 terabytes of storage in it. So I have one 4 terabyte drive that's dedicated to my VMware environment, and then I have 8 terabytes of storage that's dedicated to my home LAN. So like anything that's on any of my home computers is dumped off onto my storage appliance, and every year or two I need to go and buy a new one so that I can move files over or have as a backup or whatever the case might be. The point being is that switch provides the connectivity between the storage appliance and whatever devices I need to connect to. The cool thing about it is whenever you take that switch and you plug devices into it, and those ports that you plugged into are in the same VLAN, same layer 2 broadcast domain, that's perfect, because then that's going to allow those two ports to communicate with one another. That's exactly what's happening here, right? Because you have no idea what's actually happening. The switch is just moving traffic from one port to the other as fast as it can. That's its job. And that's basically what's happening here. So when we talk about how that would actually operate, you're taking into consideration those details. So in the event that I need to separate two different customer traffic from one another, there's two ways you can do it. You can do it layer 2 and you can do it layer 3. If you're doing it layer 3, we've already covered that in MPLS VPN with layer 3 VPN, where you use route target values and route distinguishers, and route distinguishers make the routes unique. Route targets determine who can send and who can receive, things like that. Where in layer 2 VPN, you don't have a route target value, at least not until you get into the BGP auto discovery for VPLS. Then you'd have route target values, but that's a whole other that's a whole other topic domain that we're going to get into down the road. Right now, we're just trying to understand the basics to how layer 2 VPNs work in terms of their operations. So now that we understand those components, that's the main thing that I wanted you guys to take away from this. So let's take a look at this in a little more detail about the concept of having a router. And let's draw another router over here. Actually, let me move this over. We have this router here, and we have this router here, right? We have some sort of infrastructure between these guys. He's connecting down here, he's connecting down here, so we have PE1, and we have PE2. We have an attachment circuit going down to a switch, right? And this guy's got an attachment circuit going down to a switch as well. Then I have a breakout, meaning that I have, let's say this is, this could be any location. It doesn't matter what it is. But I could have a mall, for example. So here, for those of you that are not in the U.S., we have malls. I've never been outside the U.S., so I don't know what you guys have. If you guys have malls too, maybe you call them shopping centers or whatever the case might be. Strip mall, we have these locations where you can go to a mall. Like, for example, I live in the Milwaukee area. There's a couple of malls. One of the ones that I've been to a few times is called Bayshore. It's right against the Lake Michigan. And when you go there, they have a couple different places in Bayshore Mall that you can go to where internet circuits and service provider networking terminates, and then it follows the fiber infrastructure to wherever it's got to go. So one of the things that they do there is they have breakouts to where, let's say, for instance, you could have, I don't know, we have Spencer's. Could be one. There's one. Then you can have, Hot Topic. Then you could have, I don't know, Pac Sun for Pacific Sunwear. Then you could have Oakley. Then you could have, I don't know, like Apple. And you could have Samsung. And then you could have Samsonite. Right? So you have all these companies that are leasing space from the mall so that shoppers can come visit them. So in the event that you have the switch, you can actually take and you can run a connection to each one of these individual locations, right? And the cool thing about it is when you're doing it, you're providing a independent connection. So let's say this is, again, VLAN 10, 20, 30, 40, 50, 60, and then 70 down here. So you just configure this as a trunk. And on this interface right here, you would go in here and you would allow VLANs 10, 20, 30, 40, 50, 60, and 70, right? And then what would end up happening is now I could have this connection set up right here, right? Well, that's going to give me a lot of flexibility. And that's going to be what they call Ethernet flow point, or EFP. The idea is this is one specific connection. So this would be what they refer to as a service instance. The service instance, or SI as I like to refer to it, is where you would specify the encapsulation. So you would specify encapsulation .1Q, and then you could then start saying, okay, I want to match on these specific VLAN IDs and things like that. It's going to give you a lot of flexibility. So I'll add a switch in here just so you guys can see what I mean. It's actually pretty straightforward for the most part. But this would allow you to break out this configuration and get it working a little bit more cleanly. So you could have this set up in such a way to where, like, Spencer's is on VLAN 10, and then you'd have obviously VLAN, you'd have all these VLANs created right here, and then you would map them to those unique ports, just like you would on a regular switch that you're configuring inside of an enterprise environment. That logic does not go away. And then the device that you're terminating this on could be a router, right? You could have a router that's terminating into this connection, and then this could be a .1Q subinterface. So you would say it was a gig 0/1.10, or whatever the idea is. And then you would give it an IP address of, let's say this might be public internet right here. You could deliver layer 2, you could deliver public internet this way, or you could drop off layer 3 connectivity, because it's all layer 2 up to this point, right? It's all been delivered that way. And so you could deliver that, and then you could give this a public IP. This could be 21.6.8.9, right? And this could be a layer 2. You could be delivering the transport and the internet service by a layer 2, and then you could go and set up an IPsec VPN. You could do DMVPN. You could do a bunch of different capabilities, but it would all ride out through here. So in the event that you can't run a single terrestrial line or physical connection to the location itself directly from the PE router, you need a breakout. It's one way of doing it. So in situations like this would be a very common thing for people to roll out. Now you could have switches in the back end here and then make this a trunk link as well. That's also possible. I've never seen a customer do that before. Usually when a layer 2 circuit, or whenever a connection is delivered to a suite, or what's the word I'm looking for? Let's just give it a unit number in the mall. You drop it off at a unit number in a mall location, and that particular customer comes in and sets up their infrastructure, and they're going to physically plug that connection in. It comes online. Everybody's happy. Those type of connections are typically going to be more complex to set up than it would be just to terminate the connection via router, which is why I chose the opposite to go the direction I did. But I'll add in a couple of switches just to show you what that would look like, and a couple of routers attached to it, so we can see how that would come into play from a MPLS perspective. So now the same thing can be delivered over here, right? You could have, like, this could be the data center side. So this could be the we'll call this the service side, right? Because you have customers that you're servicing here, and this will be the DC side, where you've got, your point of sale machines or your databases and things like that. And then this could be a trunk link, and you could have VLAN 21, 28, 36, 40, etc. And what you can do is, as traffic comes in here, you could actually take, say for example, VLAN 10 coming inbound on this PE router on this attachment circuit, and then you could rewrite it to be VLAN 21 going out over here. So because what ends up happening is, between the ingress on PE1 and the egress on PE2, you can rewrite whatever values you want. So I've always struggled with this particular aspect of it. I know it's possible, so I'm going to attempt to, in this series of videos, to make it actually happen and all that type of stuff. I'm taking a different approach to my study habits. So there's that. But when you bring the traffic in and you push it out towards PE2, you can rewrite it to where it comes out as a different value. It makes it easier if the values are the same, because then it's easy for most people to maintain that logic to where, especially me spending a good portion of my career in the enterprise, where you don't rewrite VLAN IDs. VLAN IDs are propagated to a layer 3 termination point, and that's as far as it goes. But here, in between here and here, right, in between these two locations, the actual VLAN IDs are stripped off, right? Because then, as it's move from a VLAN ID, that is pushed over to a VPN label and then forwarded on to wherever it's got to go. And that's basically how this construct comes into play. So then the traffic is dropped off, and then that's when you have the opportunity of rewriting the VLAN ID and things like that. So it's very, very cool what can be done and how all that type of stuff works. But that's basically the operations of how it all comes together. So the last step that we want to talk about is going to be the Pseudowire. And there's a ton of different things that you can throw at the Pseudowire. So we talked about X-Connects. X-Connects are any transport over MPLS, and then you can stuff like that. The Pseudowire class comes into play, but there's a number of other things that can be used where you're letting the Pseudowire itself to dynamically created. Where here, as we're continuing on, we're going to be manually creating a lot of pseudowires, going through, point-to-point connectivity. I'll take you guys through the logic of the old layer 2 construct and then the newer layer 2 VPN constructs, mainly for the fact that I neglected to spend a ton of time on the old legacy L2 variations of that. And when I got to the CCIE lab, I was like, okay, I should have spent a little bit more time on that. Because I knew the layer 2 VPN, CLI, so going into the bridge domain and all that type of stuff. So some of the things that I saw in the SPCCA lab, I was like, I did not spend enough time there. And so my goal is to go back and hit that lab again sometime in 2020. But, with the way things are going now, I don't know if that's going to happen. But I figured it's worth the refresh and going through the material and stuff like that. Plus, it's one of those things where it's like I feel like I've put 3 years of my life into this and I haven't gotten anywhere with it. So, got to do something with it. So, hopefully, passing this knowledge on to you guys will be helpful. So, that's basically where that comes into play. We're going to spend a lot of time in pseudowires. I'm not going to go into a in-depth breakdown as to how the pseudowires are actually built because I want to use, I'm going to be covering that in the videos. So I don't want to take any, a bunch of additional time here that I'm just going to be repeating over and over and over again multiple times from here on out. So with that being said, I'm going to go ahead and end this video here, and we'll take a look at going through and setting up some pseudowires in the next video and getting things up and running. I'm going to walk you through. I'm going to start with the older stuff first, and then I'm going to walk you through the newer stuff later on, and then that's going to grow into point-to-point pseudowires connecting router 1 and router 3, and then I have a bunch of other connections in here that we're going to take a look at. High availability scenarios, backup connectivity, that type of stuff. And then we're going to go and transition into other capabilities like VPLS, HVPLS, BGP auto discovery, all that type of stuff is going to come into play as we progress. So until next time, guys, thanks so much for stopping by and hanging out with me, and we'll catch you guys in the next one.